E ngā mana, e ngā reo, e rao rangatira mā, tēnā koutou, tēnā koutou, tēnā koutou katoa. Kia ora koutou, and of course, as it is Fijian Language Week, a hati bula vanaka to you all. My name is Jeff Wilmot. I'm the Associate Dean Research here at Te Whare Pūtaiao, the Faculty of Science at Waipapa Tamatarao, University of Auckland. Apologies tonight from the Dean. It is his birthday, so I think we'll let him off to have dinner with his wife tonight. It's a pleasure to welcome you all to the inaugural lecture of Professor Martin Brook. Inaugural professorial lecture celebrates the academic achievements and future aspirations of newly appointed professors within the Faculty of Science. It is, of course, a significant milestone in an academic career and should justifiably be a point of reflection and pride for the new professor and for their colleagues. It's already been great to catch up with a few of you outside, and I'm sure this evening we will all be part of a memorable event for Martin and for the university community and for members of the wider public who are welcome here tonight. Martin's told me his wife is here, so special welcome there. So Professor Martin Brook is a geoscientist whose career has spanned industries and disciplines. Before joining the university in 2016, he worked as a consulting engineering geologist in Australia, contributing to major infrastructure projects, from tunnels and highways to ports and renewable energy. His research now focuses on land instability and environmental geology across New Zealand and the Pacific, supported by organisations like EQC, MBIE, and the Royal Society of New Zealand. Martin is a chartered geologist with the Geological Society of London, an Engineering New Zealand professional engineering geologist, and a senior fellow of the Higher Education Academy. He's also deeply involved in outreach and training in the Pacific Islands and serves as a chartership assessor for geoscientists around the world. Tonight, Martin will explore the critical role of geoscience in society. He'll also share insights into how we prepare science graduates for the workforce and the importance of work-integrated learning and lifelong professional development. Please join me in welcoming Martin to the stage.
Okay, Bula Vanaka, kia ora everybody, thanks for coming. So I'm going to touch on a few things today, mainly about geoscience, but also how it relates to society and how it's done so through my research and my teaching and some of the student projects that have been done with me over the years. You know, some of the more interesting things I've been involved with. So it's not going to be highly technical or anything like that, so sorry. If you wanted to come and learn about INSAR, Matt Cook is somewhere in the room, so you could ask him. And I'll talk about, I'll just structure it like this, a bit about education, formative years, then my career, and then some research as well. And you'll see that geoscience and society is kind of, hopefully, interwoven through it, a bit like a golden thread. Just a bit about my background. So I'm from East Yorkshire in England. And my first experience of geology was my GCSE, which would be years 10 and 11 now. And we had a really good GCSE geology teacher who took us to a quarry, which was my first experience really of geology with someone, you know, obviously the teacher had done a geology degree, so he knew what he was doing. So we went to a Ullitic limestone quarry, which, you know, for a school teacher to organise that for a school was probably a big thing, even back then with health and safety in the... Got to be about 1990, something like that, I think. So that was Wath Quarry, Ullitic limestone. And I actually went there and I thought, God, this is the last place I ever want to work. I thought it was dusty. I used to get hay fever, so the dust, you know, made me sneeze. So I thought, I'm never, ever going to work anywhere like this. And I did actually sometimes work in quarries. Then A-level geography, which we had, was years 12 and 13. And this is the Holderness Coast. And that's when I think, you know, teachers started telling us a bit about long-term climate change and things like that. And this is the Humberside or East Yorkshire coast on the left. Let me just change this to laser pointer. And this is the present coastline. This is about 50 kilometres along here. The North Sea, or if you're Germans, it's the German Sea. And this is the coastline in Roman times, 2,000 years ago. So there's been about 3 kilometres of cliff recession in 2,000 years. And these are all the lost towns which don't exist anymore. So over, the Romans and, Christians, churches, all the rest of it, they're very good at collecting taxes and things like that. So there's very good records about these villages that don't exist anymore. So a massive amount of erosion has occurred. And just looking at this image here, this is the cliff line at Aldborough, which is about down here in 1855 on this old map. And this is what it was in 2000, 145 years later. So about 200 metres of recession, no more Talbot Hotel, no more Spa Inn. And the cliff recession has been even greater. And my great-grandparents had a house at Aldborough in the 1950s, and that has long since gone into the North Sea. And it's an interesting part of the coast, and I didn't really understand this at the time, but I do now. Along that whole 50-kilometre section of the coast, it's just unfortunate that bedrock doesn't outcrop at sea level. Unfortunately, it's this laminated silt. So this would have been covered by ice during the last glacial until about 16,000 years ago. There would have been a big glacier over the north of England, including this, and towards the margins, meltwater lakes. And unfortunately, laminated silts like this, with very pervasive bedding planes, outcrop at beach level across a lot of that coast, tens of kilometres of the coast. And it's just one of those geological aneurysms, because if the laminated silts weren't there at beach level, we wouldn't get very large landslides, rotational landslides, which cause a massive amount of recession. There'd still be recession, but it wouldn't be the level it is. And it's just an unfortunate situation. Because this is what happens. This is from the British Geological Survey. There's that Dimlington bed of laminated silts, and the shear planes form in there and form these huge landslides. Now, largely that coast is one of managed retreat. The council can't afford to put coastal engineering on 50 kilometres of coast, but there are areas like the gas terminal where the North Sea gas comes ashore. That is, there's a lot of engineering there. But the problem with that is we all know that wherever there's engineering, there's probably going to be an edge effect along a coastline. And, we've got the north to south longshore drift, and sure, the engineering does its job. We get accretion, but some sediment build-up on the northern side of the groin. The downdrift direction side of the groin, it's all depleted from sediment. And you end up with these kind of edge effects because the cliff is no longer able to add sediment to the beach and build the beach up. And this is a classic here where, we've got some kind of coastal engineering there. Looks a bit number 8 wire, but, and then, we've got this edge effect here of increased erosion. So along that coast, it's rapidly eroding. It will continue to do that. And remember, the Holocene, we've had 5,000 years of reasonably stable sea level, and the recession has been massive. So just imagine what it's going to be like with increased sea level. I then went on to Leicester University, and I did the BSc geology there. And it's one of these old red brick universities down in central England here. And for me, it was a real eye-opener. We did 2 weeks field mapping on the Isle of Arran in Scotland, which is a real mecca. Most geologists would have been there at some point, hopefully. Did a week on the Craven Faults, 3 days in the Precambrian in Charnwood. It was an unbelievable amount of field work. And remember, in England, you do a degree, not a major. So you're not just, your whole of your studies is in geology. It's not a third or anything like that. It's a degree, it's not a major. So you study quite a lot. And we went to Hutton's Unconformity. This is at Loch Ranza in Arran, and a very famous tourist area. You can see the unconformity in lots of other places, but this is quite a famous one. However, there was a big problem with Leicester for me, because I'm from Hull. I'm from the north of England. And there's a north-south divide. And they don't play rugby league in Leicester, they play rugby union. And in 1992, there was no internet to speak of. And I thought everyone played rugby league, the 13-man code. And that was my game. So I was disappointed when I went to Leicester. The great university, but there was no rugby league. And in fact, rugby league's only played along this M62 corridor between Hull and Liverpool. So that was a big problem for me because I like to do things outside of academia. You know, I love studying, but I like to do other things as well. I like distractions. So I gave that up and I went home and back to Yorkshire and played rugby league for a year. And this is the team I played for. Some of these guys are still in prison, I think. One or two of these. One of them is on a life sentence. And some real rough characters. This is some council estate somewhere in Hull. And you can see it was sponsored by Coors Beer, so the American brand that we're trying to break into the market. And the pub that sponsored us paid for these shirts. So I did that for a year, worked in a meatworks, that sort of stuff. But I thought, I've got to get out of this, otherwise, you know, I'm not going to do anything with my life. I'm probably going to be in and out of jail with these other clowns. So I went back to university. Now, my A-levels weren't brilliant, but they were enough to get into university. So I went to Salford University, who I knew had two really good rugby league teams at the university. And but they didn't offer a geology degree, but they did geography. And I was very lucky when I arrived there because this guy, Mark Tippett, had just arrived. Now, Mark, on the staff there, about a year before. Now, Mark, some people probably know him. He did his PhD with Peter Camp at Waikato, fish and track analysis. Before that, he'd done his bachelor degree at Vic in Earth Science with Mike Crozier and people like that. So Mark arrived at Salford University in the geography program about 2 years before I arrived, and he started reinvigorating the program. And it's amazing the difference, you know, that a catalyst like Mark can make to a program, because, you know, the staff members there, they were good, nice people, wonderful, but they'd been there 30 or 40 years. There was a lot of Misters and Mrs. You know, they weren't research active. Mark came, reinvigorated everything. And, you know, I guess the way he redesigned the course, it was more like an earth science degree. So we had tectonics. We had a tectonics module. We had a double module of applied geomorphology, applied coastal geomorphology, mountain, remote sensing. We had a field trip to the Beatic Cordillera looking at tectonics. We had a lot of landslide projects. I did my own. In England, you do your honours dissertation in your third year of your bachelor degree. You don't need to stay on for a fourth year. None of that. It's all just done in your third year. So, so I did that, and, you know, Mark, you know, he did a great job. So I learnt a lot, and I thought, yeah, actually, I can do this. And you know, Mark was teaching us about some of these bedrock depressions in Wellington. On the other side of the world. And, you know, Marc-Andre Brideau, one of my predecessors here in this role, who some people here know, Marc-Andre was still studying this thing, you know, these issues in Wellington only 2 or 3 years ago. So I got a good insight into what was going on in different parts of the world from that geography program, which was really good. You know, these are rainfall triggered events that we get down in Wellington. Second year tectonics field trip to southeast Spain was absolutely brilliant in the basin range topography. We met the mayor of the local town. He showed us all the earthquake damage to buildings. There's me in my Manly Sea Eagles shirt walking. I don't know. I was probably getting some San Miguel's for lunch break. Or something like that. But it was a great field trip. And also, you know, you also get the opportunity to see some amazing stuff. So the Alhambra in Granada, amazing. That's from the Islamic Golden Age, where the Moors took over southeast Spain. Amazing palace. Ronda, amazing hill town with some, you know, great architecture. And I just noticed these very pervasive defects actually in the cliff there. I only noticed this the other day. So you get, I think we're very lucky as geoscientists because we get to travel around and we can do some really good bits and pieces, you know, collect rocks and soils and all the rest of it. But we can see a lot of culture as well. So we're quite lucky. I was lucky enough also to do a third year applied geomorphology. This was a double module, so I guess like a 30-point paper here. And we studied the cliff landslide in Salford. In Manchester, which is locally called the Lanny. And it's very close to where Manchester United's training ground was, at the cliff. This is the landslide area in 1848, around here. And then this is the more recent hillshade LiDAR. And you can see, you know, it's quite undulating topography. It kind of looks like a landslide. And that's the... so you've got the River Irwell at the toe, and, you know, every few hundred years, there'll be a flood which will then take away the toe. So I had to do a 2D section of it, like this is what I did. And you can see this again, climate change was very important here because Manchester, that area, was at the southern end of the British ice sheet. So lots of meltwater until about 15,000 years ago. And it was a glacier fluvial deltaic sequence. So, these clay layers, which, created perched water tables, and then very loosely compacted sand in between them. So spring lines on top of the clays, and that was another destabilizing factor. And it was really good. We got SPT data off the council, boreholes. We took samples for lab particle size distribution, did a geomorphological map. And, there's the Chester sandstone underneath. And, in floods every 200 or 300 years, the river oil increases discharge and cuts into the toe and causes reactivation. But it's still active today. And just, we had the couple of books we used were Waltham's Foundations of Engineering Geology. It's still about in its 4th edition. And Mike Selby's Hill Slope Materials and Processes. Obviously, Mike Selby, he was VC, I think, at Waikato University. So he wrote lots of tech. So we had quite a lot, and this would have been full of New Zealand stuff. But that's what the headscarp of the cliff landslide looked like in 1932. This is what it looks like today. That house there, I think, is this one here. So not much setback distance from the top. This is just a blast forward a bit. I just had a look the other day. This is the latest satellite radar, which is on the European Ground Motion Services website. And there's that little circle there. It's just above the headscarp of the cliff landslide. And you can see it's still moving. That's from 2019 to about 2024 here. And you can see about 8 or 9 millimeters of movement. So the area is still moving. But this is really important. Now, this painting as well, this is William Wilde, and this is just along from that cliff landslide here. This is 1852, and this is called Manchester from Kersal Moor. And it's a very important picture. It captures exactly what was going on at the time. You're looking at the Industrial Revolution there. All those chimneys, burning coal, spitting out into the atmosphere. And the Industrial Revolution transformed society. I don't think anyone would argue with that. And in the 1720s in the UK, life expectancy at birth had dipped down to 25. By 1851, it was up around 40 years, and it's more than doubled since then. So this is really important, the Industrial Revolution, and I think this painting is very prescient because, we're dealing, as geoscientists, now we're dealing with the climate change from the Industrial Revolution. We've got now a massive population because of it. People live a lot longer. We've got better healthcare. That also means we use up resources and we change a lot of land use. And that's why people who work in our school, geoscientists, geologists, environmental scientists, geographers, that's why, we're our graduates certainly at the forefront of fighting climate change and also environmental changes and mitigating hazards related to that. So it's a very important picture, that. And I'll return to that at the end. We also did a 3rd-year applied coastal geomorphology trip to the Llyn Peninsula in North Wales. Like in Auckland, they like building up to the edge of cliffs with little setback distance. And this would have been covered by just the southern part of the Irish Sea ice sheet. So these are all glacial deposits. When they become saturated in rainfall, they fail. So we did, an engineering geomorphological map and report there, which again was great. Great field work to be involved with. There's a friend of mine looking at some of the coastal engineering. There wasn't much, but he had a look at some of it there. This is what I went to Salford for, to play rugby league, and I did. I was first team captain there after this, and then played for England students as well. But that was really the end of it for me. I'd gone there to play rugby league and do a bit of study, but by the end, I was more interested in studying. And I thought, well, look, I need to get a job. So I went and did a PhD. So I got offered a PhD scholarship at Dundee University up in Scotland. And Dundee, it was one of those, it was a bit like the UADS one here, so the university.org. So, you can build your own, decide what you want to do. So I thought, look, I've done short-term stuff, really applied geomorphology in urban areas. I want to learn about long-term landscape evolution. So I designed a project with basically about 4 chapters in it, each studying different things. And some of it even got published in Geology. Someone even cited my work. That's amazing. So yeah, I designed a project and went over to the Alps to work on Miyagi Glacier. I wanted to know, there was a lot of rockfall onto the glaciers there, and I wanted to know why these glaciers covered in rock hadn't receded like a lot of the other glaciers that didn't have rockfall on the top. So I put different sensors into the rock overlying the ice. I was logging temperature, things like that. Like the climate station, I was camped near there for about 6 weeks, collecting data. So that was interesting. So yeah, I mean, the temperature's warming, climate's warming, glaciers are receding, but some weren't. So I was trying to understand why. And, you know, some of these glaciers get covered in rockfall, and it might only be 1/2 meter thick, but it's enough to insulate the ice from climate warming, which is quite interesting. I also did some stuff in the Scottish Highlands, and this is a granite batholith which has been unroofed by a denudation over tens of millions of years. So on the plateau surface, we've got granite here, which tends to be a massive rock, but you end up with these sheet joints in it from stress relaxation, just due to the unloading of the rock mass over time. So it looks like a sedimentary rock with bedding in it, and it isn't. It's granite. And very, very close by that, you've got these very deep valleys, which would have been filled by ice during the last glacial and during the Quaternary, carving these very deep valleys out, and, you know, ice at its pressure melting point at the base. Whereas on the plateau surfaces were also covered in ice, but there was no erosion. And that's because the ice was thin. It didn't reach its pressure melting point, and it basically froze to the bedrock. So with ice, for ice to erode, you need meltwater. And you can only get it where the base of the ice is at its pressure melting point. So that was quite interesting. And then I decided to go to northwest Iceland. I thought, I fancy going to Iceland. So I went there, and I was interested there in escarpment retreat. So I'd figured out, look, glaciers can erode a lot of rock during glacials, but what happens during the interglacial? And how are these escarpments retreating? And this is the Vestfjorda Peninsula up in the northwest, and you've got millions of years here of lava flows stacked up on top of each other. Beautiful vertical cooling joints. But between some of the lava flows, you've got lignite deposits, which some of the Vikings used to burn. And that's really important for the style of escarpment retreat there. So the lignite deposit creates a basal plane, and then the vertical cooling joints intersect with that, and you get quite tall topples off the escarpment. So it's a rock topple process, which occurs in the interglacials, in the warmer periods, and during the glacials, when the whole area is covered in ice. That's the Drangajökull ice cap in the background. This area would be covered by ice during glacials. The landscape evolves in a much different way. So this was interesting as well. Time was cracking on with the PhD. It was a 3-year scholarship. I didn't want to stay in Dundee longer than 3 years. So I thought, right, I better get a grant. So I got a small grant from the Royal Society and came to New Zealand and did some stuff down in the Alps. So this is a painting from Gully in 1865, looking down on the Tasman Glacier. This is the Tasman Glacier here, believe it or not, covered in rock. And January 2000, when I was there during my PhD, and then this is what it was like when I went back a few years later. Huge glacial lake has formed, kilometers of ice retreat in a few years. So I decided to start studying this, and I actually also did some stuff on some debris lobes in the Ben Urhau range, which is just to the west of Lake Pukaki. And these are interesting features because, again, in interglacials like the present, they're quite stable. They become vegetated, but during glacials, any rainwater creates a really thin layer of a really thin film of ice on each block of grey wacky, and the whole thing starts moving. So if you can date areas of movement, then you can start dating, when the climate was colder, pretty much. I then finished the PhD, submitted 3 years and 1 month, got out of Scotland, and went down to South Norfolk. And I was a research officer there at the council. It was a very interesting time to work there because there'd been a few IPCC reports had come out by then. And councils in lowland areas like Norfolk were starting to get very concerned about climate change and future sea level rise and flooding. And there were some pretty bad floods when I was there. And it, you know, councils were suddenly having to come to terms with what can they do? They're going to have to, you know, do new plans. You know, people have suddenly realised they're actually living on a floodplain. You know, and it was causing a lot of stress for, I know, the senior management at the council. So I did that for a couple of years, but it was a very interesting time to work in local government in the UK because they were just starting to grapple with some of these climate change issues. And then I went to Massey University, got a job there. I thought I could go back to New Zealand and spend a year or two there. I guess I fell in love with Palmerston North. What can I say? So I would be lecturer, then senior lecturer, and I was teaching hazards and geomorphology. And you know, it was a good time to join. I joined. There'd been a big change in faculty, a lot of retirement. So me and another guy from England came over, and we thought, look, let's reinvigorate the program and develop some new experiential learning opportunities. Let's get the students out of the classroom. So we started a new field trip down to Fox Glacier and Franz Josef every January for about 8 or 9 days. So I used to get the students up on the glacier. We'd drill ablation stakes into the ice. We had an RTK GPS. We'd see how much the glacier's moving on a daily basis. And it was great. And those glaciers are very interesting because, you know, we've got climate warming and glacier recession. We all know the temperature's warming, but it was the first time that I'd really thought about climate change and precipitation. And these glaciers are very important down there because with El Nino, you get a few consecutive El Nino years and we get increased southwesterlies, and that dumps a lot more snowfall up into the neve of these glaciers. And then they can advance. And in fact, you know, most glaciers globally were retreating. And these glaciers from the early 80s onwards advanced more than 1 kilometre, almost 2 kilometres. Franz Josef advanced, all due to increased precipitation in the neve area. So that was important for me because I realised, look, climate change isn't just about global warming; it's about precipitation changes as well, and we see that now with landslides and what's going on around Auckland and the North Island, and warmer sea surface temperatures. We also did stuff on rockfalls and things onto the ice and looking at ice structures. And Heather Purdy, she was one of the students. She ended up, I think she's a professor at Canterbury now. She went on to much greater things. But I did start getting into experiential learning, and me and some colleagues started doing work. You know, how do students learn? How can we improve how students learn? And you got to understand how different students work and what works best. And we started doing a few things in that regard, and it was quite innovative back then, using digital cameras and things, and digital video recording. Obviously now everyone's got, you know, a smartphone, but then it was quite innovative. Some of the PhD students, John Appleby there, doing some GPR in the neve at Fox Glacier. So he was interested in the structure of the glacier, and you can see some of the yellow snow here. This is bushfire ash from Australia. That's me doing getting some snow samples from the from that crevasse and just making my way back out. I was very tired by the time I got back up. But we got the snow, and we published a paper a few years later on the isotopic signals. And then I started doing stuff at Tasman Glacier with a couple of PhD students, Claire Robertson in particular. But this is the glacier terminus here. You can see all this subaerial erosion. You can see also erosion at the notch there. So the warm surface water causes the glacier to erode. But subaqueously in the lake, there's actually a big toe of ice, which extends about 150, 200 metres south into the lake at depth. And I thought it was probably important to do with how the glacier recedes. So we started doing work there. We had a little tinny, a towfish sonar towed behind. Really, this would never happen these days. But it was great work, and it all got published. And I learned that inflatables and argillite rock don't mix. So we went through a few inflatable boats as well down there. And Rob Dykes there, he then came to do a PhD. So Claire had worked out about this big foot of ice underneath the water in the terminus. So the terminal cliff doesn't go straight down at the terminus there. It actually ramps out under the water about 200 metres further south. So Rob set up a broadband seismometer. Gert Lube got on board, another academic down there, put in video cameras and things, and started looking at how the glacier was breaking up. And it was really, the key thing was water level change in the lake. So increased meltwater and rainfall increases the level of the lake. The ice foot that's in the water then has a bending moment into it. The cracks propagate up from the base, and you end up with a massive breakup of the submerged ice foot into icebergs like this at the surface. So Rob captured that quite nicely with the spectra he was looking at. I also did stuff in the Tararua Range with Tyne Crow. Tyne somewhere, there he is. Yeah. So we dug some pits, got some tephra. So this is about 30 kilometres north of Wellington. This would have been full of ice during the last glacial maximum. So we got some tephra, dated it. We also got did some beryllium, cosmogenic dating of some glacier sculpted bedrock and published that. And I did stuff on Taranaki as well, and looking at some of the landforms. And it's on these volcanic mountains, it's very difficult to understand the geomorphology because you've got, obviously environment, climate change, you've got, volcanic processes, all sorts of things going on. And that's the summit. I think all the ice has gone off the summit of Taranaki now, but that was the ice back then. But that was interesting work. And then I started getting back into sort of engineering geology. I bought a scala penetrometer and a few other bits and pieces. And I had a student, Erin Hutchinson, work on the Saddle Road in 2008. That's what the Saddle Road was then across the Ruahine Range. This is what it looks like now. That's not AI, that's a real photo. And it's a fantastic road. So we published that in Canadian Geotechnical Journal, looking at these weak Pliocene materials. Be interested to see how long these batters stand up like that. And then my wife, or future wife, she'd move over to Australia, and I'd had enough. And so I decided to move over to Australia, resigned, and went into the private sector. Did a part-time Master of Engineering at UNSW, and that was a massive change for me. I mean, a year previously, I'd been at Massey sending out thick study guides to distance learning students. At UNSW, it was completely different. They're ranked second in the world for mining, and that's for good reason. Even back then in 2013, when I started there, they had a VR lab, which they'd had for a few years. A lot of the first course I did was 6 p.m. in the evening, and there's people, it was via kind of a Zoom thing. This was 2013. And people were, zooming in from all over Australia at mines, taking the paper. So it was so far ahead of the curve what was going on at UNSW there. And I started working towards chartership. Worked at Ravensworth, steelworks there in the background, coal mine. These are just some examples. Curragh open cut mining, Queensland. So problem here, this was a light vehicle road, which was basically acting as a flood levee, keeping this water out of the pit. And it was never designed to be a flood levee. So there was entry holes here from when the water was impounded, and fans of material on the distal side where the fines were getting piped out. So obviously the surface then started subsiding. So we did an investigation of that. Underground at Cabra Downs mine there. This is the coal face. This is right at the top of the Permian. Above that, a few meters above here, is the Triassic, the extinction event. And above here, you're into all the green rocks from the Triassic extinction event. This is the roof strata control. Obviously, these roof bolts aren't doing it. They're not holding anything up anymore. Got out there quickly. And then we did a lot of abandoned mine work. So obviously, in areas where the mining has occurred decades previously, that land is then at some point going to get redeveloped. And this one at Maryborough, often you get crown holes like this where a mine void it could take decades to propagate up to the surface. Like this, and then that's a problem. And this was going to be a residential subdivision. And I think it is now. So that's what's on the smoker. I've got my snake gaiters on there. So it must have been quite a snaky, because I didn't often wear snake gaiters, but at this site I did. So it must have been quite a problem on that one. Then I worked in Perth, Forestfield Airport Link Tunnel. So the Perth Transport Authority wanted to put a big tunnel under the Swan River. And that's when I first worked airside. So I'd got trained up to how to do seismic surveys, shallow seismic. And that's the first time I worked airside, and trying to find time between, it's a busy airport, Perth, where you can, do a seismic survey with a propelled drop weight like this to put enough energy into the ground so there's enough signal over the noise of the aircraft. There's a lot of downtime, and you can see how some ground investigations blow out. Worked in Northern Territory. This is Tyndall, Mid-Cambrian limestone. The US, I think it's all in the news anyway, but the US military spent $2 billion extending the runway in the Northern Territory. I think you can probably guess why. So the US military wanted the basin to extend the runway to put their bombers on it. So we were involved in a massive ground investigation there. That's me. I think just with the heat and humidity there, it was in the 40s most days. I think I'd probably lost it by then. Over water drilling in Sydney Harbour. I also did some wireline for them. So that's my Mount Cypress winch there, tripod there, and the wireline tools going down through the platform. I didn't have any issues on here, but I know on one of these, there was a punch through where, as it's getting jacked up off the floor, punched through some weak material, and the whole thing tilted, and people were, terrified, I think. So I never had any issues, but they can be quite difficult places to work, and even Sydney Harbour can get quite rough as well. So getting on and off on the tender wasn't easy. Worked in the Middle East, in UAE, at Barouge, at the oil refinery. They had a lot of subsidence issues, and that was great. This guy, Adil, he's a great guy. And you go to some interesting places. And I mean, he'd fled Palestine with his young family, moved to Iraq. Then the Americans invaded Iraq. So then he had to move to UAE. And he's so he's an interesting character. You meet some really interesting people and get to hear about what you read in the news, and then you get to see it for the real thing. And from straight hearing people who've lived it. And he was an interesting guy. He's in the oil industry in Canada now, making an absolute fortune. So he did well. Yeah. So it got to about that time, and I'd spent about 4 years, and I saw a job I was quite interested in what I was doing, but I was doing a lot of traveling interstate. I worked in every Australian state, and had a young family, and we saw this job, and my wife said, "Oh God, that looks like you. You should apply for that." So I did, and I got the job, and it's been very productive. I've had some great students, been lucky with funding, and my research is more engineering, geology, a bit like what I was doing at Salford in my undergrad degree. It's kind of an extension of that, and come up with some teaching and things. So I take students to coal mines so they can say, look, this is where the filth comes from. That's damaging the atmosphere. This is it. We shouldn't be mining it, but we still are for some reason. This is Tom Rishworth from KGA there, and some students doing a landslide there in Gisborne, some third years. Do some other stuff beyond the academy. So this is doing some outreach in doing some training with the minerals department in Fiji. So they're very good, really good geologists, very strong mineralogists in Fiji, but they tend not to do any engineering geology. So I went over to try and upskill, and I'm a chartership assessor as well. So I do chartership assessments for people all around the world. So I get to see what people in the industry are doing all around the world, which is always quite interesting. This is just a snapshot of some of the research I've done from some real weird and wonderful places, and obviously got into the environmental geology with all the erionite and that kind of work as well, and toxicity as well. Students generally mind, they might do some geophysics. Maybe there's a CPT rig. There's Ariane, one of the students, the CPT rig doing that for her. Gabriel there doing some stuff in the lab, and we've got a shear lab, so we do direct shear testing as well. But probably the most promising thing of the last few years is the INSAR stuff, especially Matt Cook's PhD funded by EQC, and then Harry Lecheminant's stuff at Murray, which is going to be published hopefully soon for his masters, and then obviously Wally's taking this forward with his PhD in Gisborne as well. So this is satellite radar from space, where you can get really high resolution understanding of what the ground is doing, which is really important for planning and for some councils' decision-making, especially in Gisborne, where they've got a unitary authority, and someone like Murray Cave there can really make good decisions with good inside data. Some of the landslides there, I'll just hurry up and finish in a few minutes. It can be, when you visit a property to do an inspection, it can be this is one I did in Gisborne for the council. You enter a property, and the effects can be very subtle of a landslide. Look, it's got a red sticker on it, a red placard. What's going on? And sometimes it might be a very subtle 30, 40 mil bulge in front of a retaining wall like that, or it might be some separation, or it might be a tension crack with some radial cracks just peeling off it like that. And then you go into the house and you can see, look, this is seriously damaged. You've got a landslide which is basically coming to the back of the house here. You can see why it's got a red placard and they're never going to be going back, which is terrible for householders. Do other stuff as well more in the Pacific Islands. I'll be in New Caledonia. This is above, these are the villages below Mont d'Or in New Caledonia. A lot of debris flows happen there, and there's a lot of damaging effects with the villages and townships. This is Yale from the French Geological Survey who I work with there. There's a lot of engineering to try and channelise some of the flows that come off chutes and galleries, but it's a real problem area around the slopes of Mont d'Or. And this is in Fiji with a few people in here, and Seru, the village head. It was an interesting day, that one. So just finally, I really believe that if it's not being ground or being killed, it's come out of a mine or an oil field. And whenever we buy something, I think we should appreciate that. So I've written a few things on this because I think in New Zealand we do like offshoring our environmental footprint. And Greenpeace, they weren't too happy. They said Martin Brook's opinion piece was a sad display of corporate selfishness. I think they're wrong. And I think, we should be fully aware of the resources we're using up. It's very, very easy for us not to be. And, minerals in a smartphone, we've got tantalum in all our smartphones. It comes from the DRC. And it's in everyone's smartphone, and the EU listed it as a conflict mineral. Just quickly, Stratford Imperial bricks. This is for sale in the UK. 95 pence a brick. It's about $2 a brick. They look wonderful. You'd think this is from London clay in Essex. It's not. It comes from a floodplain in Bangladesh. So people are digging up floodplains in Bangladesh, probably one of the most floodplain regions of the world, destroying rice paddies to produce bricks, cheap bricks for the UK market. These people, who are halving their life expectancies, doing this. So I think people should be aware of what they're buying. And is a cup of tea really only worth 7.9 cents? Well, it's not, because China clay for the mug and the saucer, iron ore and coking coal made the spoon, and it also causes landslides. So this is tea cultivation in Sri Lanka. They chop down the natural forests, put tea cultivation in, and this causes landslides. There's no canopy cover anymore. Heavy rainfall, deeply weathered soils, and this is what happens. So people need to be aware, I think, of what they're consuming, and that the cost they pay with their credit card is not the full cost. There's a massive environmental cost, and also the cost in terms of lives for some people as well. And just back to this thing finally, Laurie Parsons is a geographer in the UK, I think he's at King's. And he's done quite a bit of work on this, this supply chain of raw materials, factories, transport companies, shop and consumers. And just back to this William Wilde picture from Manchester, looking from that cliff landslide, we've got the Industrial Revolution here, and we've done very well with life expectancy. It's been great, the Industrial Revolution. It's transformed us. We've gone, in 300 years, our life expectancy has gone up from 25 to 83 years. But that's come at a massive cost. We've got now global warming and various climate changes going on. We've also got a massive population now and a huge demand for resources and land. And now we're building in places that we shouldn't be building for certain. And that's the River Irwell there. So it's a very useful picture, this, that William Wilde painted back in 1852 from the cliff landslide in Salford. Finally, that's my last game of rugby league in the Taranaki. That's where it all ended a few years ago now. And thanks to the funders, students, colleagues, technicians, New Zealand Industry, and my wife, Amanda. She's here somewhere. There you are. Yeah, thanks very much.